Okay, guys. So last time the last lecture, we were at this point where we were going to discuss the for loops. Let me remind you about the other videos, the other lectures. This can be found in my channel in YouTube. It's this one. So this is lecture 1 and lecture 2 with 2 parts. So let's continue with for loops. If you have any questions, we can discuss after the recording has been posted in the end of the lecture. So the for loops actually allow us to run through different collection of several items, like, for example, series of numbers, the letters of a word, arrays, or even lists. So let's see some characteristic examples of for loops. For display digit in, this is a built-in command in Python. Digit, print display digit. So basically, it's going to display and print all the letters of digit. So for display in string 1, 2, 3, 4, 5, print display digit. So it's going to print the numbers 1, 2, 3, 4, 5, 6. It's very important here to quote that we have to enter numbers into this function, the string. So it's going to make it string. If we used 1, 2, 3, 4, 5, 6 without this one, it wouldn't understand that it is a number. So let's apply the for function, the for built-in function command for the list, which is defined globally. Look at this. We define globally the list with these entries. What I mean globally, it's not defined inside the function, but it is defined globally. If I press this one, it's going, of course, to display the list, but also note that this is a global variable. List is a global variable. It understands, Python understands that list is this one. Okay? So let's consider the tuple. It's a globally defined tuple 1, 2. So for display digit in this tuple, print display digit. So it's going to display 1, 2. These are very simple examples. Let's consider a number of numbers. So range 5 means that we start from 0 until 4. I'm sorry. But it counts 5 numbers. So for index in range 5, print index, and it's going to print 0, 1, 2, 3, 4. Always remember that Python starts to count from 0. So if I want to print 5 numbers from 0 to 5, it's going to print 0, 1, 2, 3, 4, and it stops there because these are 5 numbers. So for index in range 5, 7, it's going to print the index. So the numbers between 5 and 7, it's going to print 5 and 6. It doesn't print 7. Let's define another global list with for which the entries are basically some expressions, some words and some expressions, not mathematical expression, but word expressions. So we define list with these entries. The command built-in function len, actually it's length. So it basically yields the length of a list or of some other format we're going to use. Here we use a list. So len list is going to print the number. So suppose you have a lengthy list. If you have, these are only 5 entries. 5 entries. If you have a lengthy list, you can learn with the command length, the length of the list. So let's play with for loops now. For index in range length list. So the range in the range is determined by the number which is equal to the length of the list. So print index. So the length of the list is string len list. It's very important if we are going to concatenate words and expressions with numbers to use string. This built-in command. This is this built-in function in Python. So it prints 5 because the length of the list is 5. Also, it prints the index with this command, with this for loop. So another interesting application is in the case that we want to print the elements of the list and not their number or even some elements of the list. So this is the list again. I could use this, the definition of the list from the previous one, because I defined it in a global way. This is a global definition of list, but I also quote it here. So len list is going to print, it's going to count the length of the list. And I'm going to print this one. So the length of the list is this one and string len list. So it's going to print the length of the list is whatever it is. So for index in the range of the length of the list, print list index. So it's going to print basically all the entries of the list. Let's run this. So from this one, we get the length of the list is 5. Okay. So with this for loop, we actually print each entry of the list. You can play here. You can change this number. You can take, for example, 3. You can you do it as homework. So let's combine the for loops with some other commands. These are very, very useful commands. These frameworks, the combination of for with other commands and other functions, especially in programming. I use it for neutron star programming, these for loops and combinations. For index in range 5, so basically 0, 1, 2, 3, 4, if the index is not equal to 0, this command here means not equal. Equal means equal. Not equal is this exclamation mark plus equal sign. If the index is not equal to 0, print index. But in the other case, if this index is equal to 0, print this is the 0 index. This is a very simple program. So basically, we expect at the position that the 0 would be printed to be printed to this expression is going to be printed instead of 0. Let's run it. Okay, this is the 0 index, and we expected this. Let's consider another example. For index in range 5, so 0, 1, 2, 3, 4, if the index is not equal to 0, print the index. Else, print this is the second index. And as we expected, if we run this small program, it's going to print exactly what we expected. And at the position of 2, it's going to print this is the second index. So how can we use for loops to define a function that we want? For example, an exponent function, 2 to the power of 3. This is a quite useful technique in order to define functions, not only simple functions, just as this one, this exponent, but we can define more complex functions. But this is a very, very, very first example, just to see how we can use for loops to build functions and several applications in Python. So let's see the program here. I'm defining the function raised to power. So I'm going to need 2 entries, the base and the exponent. So the base, I defined it as an input from the user. So it's an interaction of the program with the user. So I need an input. So the function raised to power is going to need 2 arguments, the base and the exponent. The base is a number that is going to be inserted by the user. And the exponent, again, is a number that is going to be inserted by the user again. So the function is going to return base to the power of the exponent. So I call the function here. So what should I expect? What should I expect is to find some interface, some interaction between the computer, the Python program, and the user. Instead of this, I'm seeing this problem. The name base is not defined. So what is the problem here? Basically, the problem is that Python does not understand that this input is a number. So we must transform this to a number. So a good idea is to use float. So we define the base and the exponent as floats, float input. So the program is going to communicate with the user now, and it's going to require two numbers, two inputs that it's going to transform to numbers. The base and the exponent. I defined the function raised to power with two arguments, the base and the exponent, and what is going to be returned to the user is the base in the power of the exponent. So I'm going to call the function here, and normally I expect that the program is going to ask from me two numbers. So let's play. The first number is 4. The exponent is going to be 2, for example. So as expected, the function returned 16. Now, two comments. Firstly, the base and the exponent inputs are globally defined. What I mean globally, they are not defined inside the program. So if I call here, for example, base, it has a universal number, a value, which is 4. So the user entered the base number, and the program assigned to it, to this variable base, a globally defined value, which is 4, what I gave it. The same applies for the exponent. If I use these definitions inside the functions, these variables would not be globally defined, so they would be defined inside the program. I did this here. So I may change this one just for an exemplification of what I said. So I defined this as base 1 and exponent 1. So let's run the program. Base number and exponent, base 1 here. I did a mistake here. So let's stop the program again. And exponent 1 here. I forgot it. Base 1, exponent 1. Base 1, exponent 1. I changed everything. Let's see. Base 1 is not defined. Let me see. Stop. So what I explained earlier is that if we define base and exponent inside the program, it's going to assign the values that I'm going to use as input for the program only inside the program. So the point is here that, for example, here I used the base and the exponent, and I entered the base 4 and the exponent 2. These are globally defined variables, but here I define them as internal variables in the function raised to power. So let's play this for this situation. So I'm going to use like 5, the base, and the exponent is going to be, for example, 2. So I get 25. If I call base, you see that the program kept the previous globally defined values of base. Okay, and the exponent, again, the program used 2, which is the previous assigned value for the program, not the 2 entries that I ended in the last case of this program. So let's use these 4 loops in order to define the exponent in an explicit way without using these two stars, which basically serve as the exponent. They give the power of the number to the base. So let's do it in an explicit way. What I need here is, for example, I am given the base, and I have to multiply this by several other numbers or the same number. So if I, for example, want to achieve this one, 2 to the power of 2, this is basically is 2 by 2, 2 times 2. If I want this one, so I must manually enter 2 times 2 times 2 times 2. So I'm going to use a for loop in order to achieve this one. I define the function raised to power again. I start a new variable called result with the first value assigned internally to this variable equals 1. So for index in the range of exponent, which is a number, the result is going to be result times the base. And I want what I want to be returned is the new result, which is this one. So let me call the function with 2 to the power of 3. Okay, 2 to the power of 4, 16. 3 to the power of 4. So this is an explicit way of defining the exponential function in a direct way. So let's see some two-dimensional lists and some nested loops, and how to create, for example, multi-dimensional grids in Python. So I defined here a matrix with a list with 3 lines, 3 rows, and 3 columns. I call and I define this globally as dgrid. The first line is 1, 2, 3. The second line is 2, 3, 4, and the third line is 3, 56, and 12. For example, let's try to access the number 1, which is in the first column, first row. If I want to call this one, I must print from the dgrid list the 0, 0 entry, which is first line, first column. Don't forget that Python starts count from 0. So for the second row, I want, for example, second row, second column. So I must access for this number here, second row, second column, 3. And let's access the second row, third column. So it's second row, third column, so it's 4 here. It's third column because it starts to count from 0. So let's see. And I took what I wanted exactly. So basically, I give the name tgrid to the list, and the program is going to seek the number corresponding to the dgrid list according to what I gave him as input here. Okay, this is very useful for large lists, or and also for NumPy arrays, because if I have an array with 1,000 entries, it's going to be difficult to find a specific value in this range with 1,000 entries. So basically, if I write a small program, I can access the values of the list of the or of the array that satisfy a specific condition. I'm going to give example during the semester on these manipulations with large arrays or lists. Okay. These are also some other examples. I made more complex here. Each entry is a list by itself. So this is a 3-dimensional, 3 by 3-dimensional list with entries that are also lists. Okay, This is a generalization for this case. So if I print, for example, I define the D-grid list as a nested list, so it contains several lists as entries. If I print D-grid 0, it's going to print this entry. If I print the D-grid 1, it's going to print first row, second column, this one. Okay, I could use this one too. And let's see. So the first row, first column entry is this one, entry 1. Okay. Let's use also for loops and several other commands like in, if, in a specific range, or for. So I'm going to make an application for replacing words in expressions or in lists or whatever. So what I need is an input from the user, an input from the user. So the user is going to enter a word. And what I want is, if the word contains the letter K, the letter K must be replaced by G, for example. How can I do this? I define a function globally, which is replace word. The replacement entry is initially empty. So for letter in the word that's going to be required from the user, if letter is K or K small or K capital or O capital, the replacement in this word is going to be replacement, which is empty, plus G. So basically, it's going to change K or K small letter or K capital or O small letter or O capital with G. Else, the replacement is the same. It's not going to make any action on the word, and return to me the replacement. So what is going to be needed from me is an entry. I print, and in the end, I must print replace with the input given by the user. This is a very simple program. So let's run this. I'm going to enter a word, for example, K essence, a specific type of inflationary and dark energy theories. So the program replaced K with essence. So let's find another one. O typographic. So what I expected is, with the typographic error, to replace every O with a G, with a J. And it did. Okay, for example, O. This is a name. It's going to print G Rafferty. Now, let's discuss a little bit about the try and except blocks. These are kind of important commands because they offer numerous possibilities, excluding entries that without them one should use, for example, complex if statements. This is very important because it's going to make a program simpler, and the simpler a program is, the less CPU is going to consume. So let's see some specific examples, and I have some more complex examples after that. So let's try this one. The program is going to ask from the user of 2 integers, and it's going to make a division of these numbers. So try integer 1, which is an input obtained by the user, and the integer 2, again, input obtained by the user. It's going to go, so it's going to print integer 1 over integer 2. So I'm going to use the first integer here, the second integer here, and it's 0.75. This is very interesting just to understand how try is used, but there are much more useful application of this try and except blocks. Like, for example, the program that we made, the calculator program we made in lecture 1, which actually was quite complex because a specific action between two numbers was required, an operation. So if I chose division and the second number was 0, I had to use an if statement here. And if it was 0, I had to print several expressions to be shown to the user. With the try and except blocks, things are much more simple. So follow me on this one. Number 1 is a float, an input from the user, so it's going to be made a number. The operation is some operation of the 4, so it's plus, minus, multiplication or division. And number 2 is the second number given by the user. So the problem is with the number 2, if it's 0, the division cannot be performed. So I have to warn the user to use another number so I can make the division possible. So I also define globally a number 3, which is going to be used later on. So if the operation is plus, just add the two numbers. If operation is else if the operation is minus, subtract the two numbers. Or if the operation is multiplication, just multiply the two numbers. Or else if the operation is division, try print number 1 over number 2, except in the case that number 2 is 0. In this case, print the second number cannot be 0 and require again the number from the user. So this is the number 3 case which I required here to be empty initially. The number 3 is going to be a float. Give me again the second number. And it's going to print number 1 over number 3. In all other cases, if you make a mistake in the insertion of a letter, or you enter something that it's not a number, so the program is going to print, you enter either a string, so a letter, or a number or an invalid operator. So let's run this one. 4, 0, operation, division, 0. The second number cannot be equal to 0 in the case of the division. Okay. Okay, the second number is 4, so the division gives 1, as I expected. You can play with this program here. You can watch the lecture again in the web. I'm going to upload it today. So you can play a little bit with this program and, of course, extend it and modify it in the way that you want. Now, let's proceed to the pip installation processes. The pip install is very useful in Python because if I want to install a module in Python, I can use directly the command pip install python docx. This python docx is some module. You can find a lot of modules and packages in Python. This is the docx, for example, but I can give you several modules. You can find it in this website. So here you have a lot of different Python modules created by people with love in what they do, and it's very useful. For example, pip installed an ASPI, which enables you to perform complex game theory calculations with Python. Very, very useful. The docx is also useful. You can install this directly in the Jupyter interface. So you can use pip install python docx, or you can install it directly in the CMD. So the command prompt, you can pip install everything here. You can install this Python module here. If you want to uninstall something, you just type pip uninstall Python docx. Also, we can import and use the new installed Python module by calling its name, import docx. You are going to see many times here this import because it actually calls the module that you want to use. If you don't use this one, Python is not going to understand what you want to do. Okay, so let's play a little bit with this Jupyter interface. I think it's a real-time and interactive, very useful interactive way to write Python programs, because you can write comments in between, suggestions, and even add links. The difference with other programs like PyCharm is that PyCharm is directly a Python programming environment. This is a hybrid environment where you can have code, perform calculations, and also write comments. You can write comments directly to the Python, to the Jupyter shell by, for example, writing in HTML format or LaTeX, even LaTeX format. So how can we understand that this is HTML or LaTeX? You can see in the Jupyter interface, if something is in edit mode, it becomes green. Also, look at up here on the right. This edit mode, this pencil here indicates that the cell I'm working on is in edit mode. Here I can change the format. I can make it code, markdown, raw, or heading. So the most useful are these two, code and markdown. If I use markdown and I press enter, this is HTML format. It's going to make it a heading. Okay, so if I use code here, it's going to return an error because it doesn't understand what it is. So this is a markdown format in HTML. If I choose a cell without being in edit mode, the cell is going to be blue. Look at here the color here. If I am in an edit mode, double click this one. So in an edit mode, the pencil appears here and the cell becomes green. Also, I can write in LaTeX format here several other expressions. For example, let's write a mathematical expression, f to the power of 2. So it understands the LaTeX format also without using the preamble, very necessary for all LaTeX editors, or any other things that indicate that this is a LaTeX or an HTML format. Just enter the HTML code, the HTML code without preambles, or the LaTeX code without any preambles. If I want to write a more complex LaTeX expression with an integral, just type the integral in LaTeX. So I take complex LaTeX and markup languages. LaTeX is also a markup language. So basically, when I want to enter comments, I just use these two examples or an HTML format, and I use the markdown option here. How can you start the Jupyter command? Basically, you install Anaconda, and you click this one, this Jupyter link. It starts the kernel. This is the kernel running behind the Jupyter file. So when you run it, it's going to start in some browser. Here it started in Google Chrome in my laptop. So you can say the file name you are working with, you are working on, just by clicking this, the name of the file. You can change it anytime. Also, I discussed again the edit and the command mode. Basically, you can use some shortcuts in Jupyter. There are very useful shortcuts. Most important, I use it all the time, if you observed, is Shift and Enter. If you use Shift and Enter, it compiles the cell that you are working on, and the new cell, it selects, the program selects the new cell, the cell just below the previous cell. For example, I'm here. If I enter, if I use Shift Enter, it's going to run the code. This is not a code here; it's a markdown language, and it's going to select the next cell. If I want to add here a cell, I just put, I press B. It adds a cell below. If I want to add a cell above, I usually use this one, A. I type A. If I want to delete a cell, I type double D. D twice. I have the most important shortcuts here, and you can also find these commands and the shortcuts in the help option here. Keyboard shortcuts and edit keyboard shortcuts. You can make your own keyboard shortcuts and several other simple useful information by help. So DD deletes a cell, B adds a cell below, A adds a cell above, M changes the cell to markdown. For example, I am in markdown mode here. Let's make it entry. So let's make this code. This is problematic. So let's make this one again a markup. So if I press M, it's transformed to a markdown language again. C copies a cell, X cuts a cell, 0000 confirms restart of the kernel, which means that every global variable must be defined again. F, find the replace, just press F, and the program is going to seek in your Jupyter file to find specific words or expressions. I interrupts the kernel, so it stops a code. S saves the notebook, Control S saves again the notebook, and II interrupts the kernel, as I already quoted above. So there are also some magic commands. These are several commands that allow us to make contact with the command prompt. So if I press pip list, it's going to show me how many different Python modules are installed in the Python program. Okay. Now, a very important and useful command is this symbol, %symbol, plus typing along with the pwd command. It's going to show us where exactly are the Python files saved in our computer. Suppose that you don't know where the Python files are. When you start a Python program, it's going to show you the last programs that you worked on, but the Jupyter programs. But it doesn't actually show, you don't actually know where exactly is it. Well, you know during the installation, but let's say that you forgot. So if you use this one, it's going to show you where exactly on your laptop are the Python files that you were working on, the current directory on your laptop. So matplotlib, I'm going to expand this later. Also, if I write this one in HTML format, so if I type %HTML, neither, if I have defined this cell to be a code, Python is going to understand that this is an HTML file. So it's not going to return an error. If I, for example, use code here, and I delete this one, this %HTML, to return an error. So Python does not understand what is this that you write in HTML format. But if I use this one, even with a code format, Python understands that this is just an HTML. If I use Markdown, it's going to make it again a Markdown command, a Markdown cell. So this is an example of an in-cell code. Okay, I use HTML here. This is a Markdown again. So Python understands that it's a Markdown format. Also, another useful command is the time it command, because you can compare the time used by Python, the time it took to Python to compile several commands and programs. So the less time, the less CPU you're using. You can use it if you want. You can download several Jupyter formats in IPython notebooks, for example, Jupyter formats in GitHub. I also have in GitHub this several IPython files or Jupyter files regarding dark energy, a study of dark energy, which I'm going to discuss by the end of this semester. Okay, let's see this GitHub. It's a gallery of interesting Jupyter notebooks. It has numerous Jupyter notebooks, very convenient. Let's now discuss the NumPy. NumPy is one of the most important Python modules, which is numerical Python. This is what NumPy stands for. It enables us to introduce arrays and use the libraries of NumPy module to do data analysis and several other complex calculations, such as solving differential equations numerically using several techniques, and so on. So how we call NumPy? We just import. We use the command import NumPy as NP. This name is arbitrary. It's the most commonly used for people that are working with Python. So if I port NumPy as NP, Python calls the NumPy module and all its libraries. I can also introduce NumPy as npm. This is arbitrary, npm. So let's define here an array. I call NumPy, and I define the array A with this command, np numpys. So this is a NumPy array 1, 2, 3. So this is a vector. If I call A, NumPy is going to return 1, 2, 3, and this is a global definition. If I introduce NumPy as npm, I call NumPy as npm. This is again A. In this case, it's a NumPy array. Okay. So let's import NumPy as np, and it took npm from the previous. So how can we check the dimension of the array we have? So I can use the command ndim. So it basically counts the dimension of the array. The most important definition is the same. The most important command for finding the dimensions of my array is the same command. We're going to use this several times in the next lectures. where we are going to use it to find the correct dimension of the shape or the shape of the array. Okay, so let's see how it works. A shape, if you have an array here, for example, this one, this A, and I want to find the shape of the array, I type A, which is the array number, the array name, and shape. So the shape basically is a vector with 3 entries, 3 columns, 1 row. If I use this one as my NumPy array, so it's basically a matrix with 2 rows and 3 columns, and I put B shape. I type B shape. So I get a matrix with 2 rows and 3 columns. Also, you can also use the ndim command, which is also quite useful. The A shape, we also discussed this one. So if I type A, let's define A. Let's say here it is. So new definition of A. Okay, if I type A shape, I'm going to take the dimensionality of A, the A NumPy array. If I type A02, it's going to print the number that it is contained on the first line, first row, third column. Recall that 0, 0, 0 is the first row or column, 1 is the second row or column, 2 is the third column or row. So if I put 2, 2, I expect that it's going to yield the number which is contained in the third line, third column. So it has to be 5. Okay, so if I put 0, 0, I type 0, 0, I'm going to take the first number here. If I type 0, 1, first line, first row, second column number. So it's going to be 3. If I type 1, which means second line, second row, and this this column mark, it's going to type the second line, the whole second line, all the columns. So it's going to yield 3, 4, 5. So I put this one and I get 3, 4, 5. If I put here 2, it's going to print all the third line. So it's going to be 3, 4, 5 again. Or if I type, for example, 0, it's going to print the first line. So it's 2, 3, 4. So I can also print a column from a specific NumPy array. If I use a the column here, and I put 0, I'm going to print from the first line, column 0. So basically all the lines here, all the lines in the first column. Line 0, 1, 2, column 0. So I'm going to take 2, 3, 3. If I type column 1, I'm going to print the second column. So it's 3, 4, 4. So if I type here 2, column 2, I'm going to get 4, 5, 5. So an element of A, if I want to print an element of A, I just use this format that I already discussed earlier. So if I type here 0, 0, I'm going to take first row, first column. If I type 0, 1, I'm going to take first row, second column. So it's going to be 3. I define again the NumPy array as 0, 2, and the shape is basically a vector. I can print, I can generate a NumPy array filled in with zeros just by putting NP zeros 5. So I'm going to have 5 entries, which are going to be 0. If I want to make a 2 by 2 matrix with filled in with zeros, I can use NP zeros. These are very frequent modules of libraries of NumPy and very frequent commands, because we're going to use these entries as auxiliary in several sub-programs of a larger program. Okay, I can generate a 2 by 4 matrix with zeros, 2 lines, 4 columns, or 4 columns, 4 lines. Or I can make a 2 by 3 matrix with 2 rows, 3 columns filled in with ones. Okay, I can also make a 2 by 2 matrix with NP full, with 2 lines, 2 columns, 2 rows, 2 columns, filled in with 99. Here it is with 99. I can fill it in with 2 or with ones or 6. I can also fill in, generate a matrix of specific dimensions, for example, 2 by 3, with filled in with random numbers. So at this point, I generate a 2 by 3 array filled in with arbitrary numbers. Let's make another one. And let's make another one too. You see the random numbers every time. I can also make the identity matrix, which is for example, square matrix, n times n for n-dimensional matrices. This is a 3 by 3 matrix identity. So I get this one. If I get 2, I get a 2-dimensional identity matrix, or for example, 70. Can be a big one. So you have 70 entries here, 70-dimensional. 4-dimensional. This is a 4-dimensional identity matrix. If I define the NP identity matrix as A, and I define that the first column is equal to 3, so A00, first row, first column is 0, is equal to 3, you can see that if I make this change, the matrix A basically changed. Now, let's play a little bit with NumPy. And we can finish this lecture here. So I can make some basic algebraic manipulations and calculations with arrays. So if I define this array to be a vector, with entries 1, 2, 3, 4, if I add 2, it's going to basically add to every entry of this NPy array, this NumPy array, the number 2. So it's going to be 3, 4, 5, and 6. If I subtract 2, it's going to subtract from every entry the number 2. If I multiply with 2, it's going to multiply every entry with 2. If I divide with 2 by 2, it's going to divide every entry by 2. Also, if I have an NPy array of the same dimensionality here, and I add the 2 NumPy arrays, it's going to add the entries in the 2 NumPy arrays. If I divide, it's going to divide the 2 arrays. You can divide A over B or B over A. It's quite important to check if you have a 0 entry. You can take the square of the entries of the NumPy array A. For example, A square is going to take the square of the identity matrix. Let's define here again the NumPy array 1, 2, 3, 4. So A square is going to take the square of each entry of the NumPy array A. Also, I can take I can make functions using the NumPy array A. For example, I can take the design of the array A with NP design. This is a built-in function, a library of NumPy. So if I use this one, NP sign, it's going to take the sign of these numbers here, 1, 2, 3, 4. It's not expressed in rads, although, however. So one has to be cautious. If you have entries here, like okay, I define A to be this one, and let's see A. So if I take the sign now, I expect the first entry to be I don't remember what it is, 0. Let me demonstrate this clearly. It's also important to quote something that I used. I defined as NP pi, basically the numerical numpy value of the pi number. So NP pi is pi, 3.14, and so on. So if I put n pi here, 2 n pi, 3 times n pi, never forget to use multiplication here, or it's not going to understand that it's a variable. So np pi divided by 2. And I use the npi built-in function np sign, which is a sign. So what I take is 0, 0, 0, and 1. This is a very small number. It's numerical calculation. It's basically 0. Okay. So let's stop here, and we continue next Saturday with linear algebra manipulations and several other NumPy exercises, and not only.